Black holes are the densest objects in the universe, or are they? Take a teaspoon-sized black hole. How massive would that be? As a mountain, Jupiter, the Sun? Well, actually about one whole Earth, but it's still a lot. It's about this dense, and that's much more than you. But we can dig deeper. If we take a look at some equations, we see a loophole. Schwarzschild discovered that if you double the mass of a black hole, its radius also doubles. This may seem intuitive, but it means that when mass is doubled, density drops down 75%, down to a quarter. So a cup-sized black hole is 14 times less dense than our teaspoon-sized black hole. With this in mind, let's do some calculations. The average human is about as dense as water, although this does vary a bit. This is the formula for the density of a black hole. We clean up a bit, and we're left with this. We only need to plug in the mass to get the final density, which is your density, about 1,000 kilograms per cubic meter. Now the mass is about 10 to the power of 38, but the radius comes out surprisingly small, only about 400 million kilometers. This black hole would comfortably fit between the Sun and Saturn, with 630 million kilometers left to spare. Congratulations! This black hole is just as dense as you, but we can go further. Much, much further. Any black holes larger than this will be less dense than you. Let's zoom out to Phoenix A, the largest black hole in the universe. With over 100 billion solar masses, Phoenix A has a density of a measly 1.8 grams per cubic meter, which is about the density we get in a vacuum chamber. Let's zoom out even further and look at the Milky Way. If we gathered all the mass from the Milky Way, every moon, every dwarf, every planet, every sun, and every black hole, mushed them all together, and made a black hole, this giant would stretch almost an entire light year across. If this happened to Earth, you probably wouldn't be able to watch this video, but let's admire the minuscule density of this black hole. With over 1.5 trillion solar masses, this giant only has the density of 8.2 milligrams per cubic meter. This isn't really comparable to anything on Earth. Air comes closest, but it's still over 1 million times denser than our Milky Way black hole. Can we zoom out any further? Of course we can. Let's take all the mass in the observable universe, every galaxy, every nebula, everything that ever existed, and mush it all together. Once again, we get a black hole. But our black hole is different, lighter than empty space itself. It is so light that if you stood at the edge, it would take 10 billion years for you to fall into the center. And this density comes out to this, which is about 1 atom per cubic meter. This density is only found in the lonely, distant corners of our universe, which would be intergalactic space. I hope you enjoyed today's video. And as always, thanks for watching.